That's great. Thanks so much.
Right.
All right, so using NLIP to connect cloud and on-premise enterprise services. So this is a proof of concept coming out of ServiceNow. There's no promise of this becoming a product or anything like that. I just want to make sure I put that out there. My name's William Witten. I'm a principal portfolio manager out of Impact. I specialize in AI, and like I said, I got involved in this because Sean Hughes really reached out. He knows I have a penchant for hacking things and wanted to see what I could do with NLIP. So I got to cracking. So let's go ahead and jump into our agenda. We're going to go ahead and talk about our problem statement to start with. Then we'll go do a brief overview of natural language interaction protocol, just for those of you that may not have heard of it before or seen it before. We'll then do a solution design overview. I'm going to do a walkthrough of the solution in action. Unfortunately, I'm not able to show, just with all the AI note takers and some of the reviews that are going on right now, I'm not able to show the solution actually working, but I am able to talk through how the solution works. And then we also have why I used NLIP. I have a few different focus areas, including some security aspects that I'd love to cover. And then I'll be open to any questions that you have. So really looking forward to presenting all of this to you. So first thing we'll go through is this safe harbor notice. So this is exactly like I mentioned. NLIP, it's not something that I'm promising or that ServiceNow is promising as a standard or anything like that. This is just my work independently. I just met Sean through ServiceNow, so no promises from ServiceNow itself. So the problem statement, what we're trying to solve here is that AI agents, virtual assistants, Internet of Things devices, servers are all trying to interact an enormous amount. These interactions include natural language, user intent, different pieces of data, and they also regularly come with privacy concerns. And customers are also frequently trying to maintain legacy services. So these are things like, homegrown knowledge management systems or old LDAP directories, et cetera. These are the kinds of things that we're talking about today. So some of the customer challenges that exist are seeking a secure method for integrating with on-premise services. They'd like to have scalable exposure of services, and they're also looking to enable AI-powered capabilities. And our goals here are to enable flexible integration of AI tools, support connectivity to on-premise services, and address privacy concerns of exposure. So jumping into what natural language interaction protocol is as the solution to that problem statement, NLIP is designed to unify the fragmented landscape of AI agent communication. So this is a new ECMA International standard. So we've been working on it for quite a while, and Sean and the team have pushed forward an enormous amount. I'm kind of joining in here on the tail end as part of ECMA Technical Committee 56. It enables real-time multimodal interactions, and it's an umbrella protocol. So this is able to work with A2A, MCP, a few different solutions that individual customers have come up with, et cetera. And endpoints are able to maintain independent internal representations and simplifies the version control and upgrades. So the key features of the NLIP architecture. So let's go ahead and talk about those. So NLIP is designed to be modular, and it's also designed to be secure. So it has that very zero trust first type mindset. It enables multimodal messaging with JSON and supports HTTP, HTTPS, WebSocket, and AMQP as the base protocol, base communication standards, base communication protocols. It enforces security profiles for agentic systems and uses token-based authentication and session management. And it supports agent interoperability with existing technology. So, for example, I had a customer once, we were very interested in integrating their Microsoft Exchange deployment with ServiceNow. It was a really great opportunity for them to be able to have a huge number of services, but there was just one problem. ServiceNow required that you have a fully cloud deployed Microsoft Exchange deployment, and they had a hybrid deployment. So they had some on-prem systems. And so because of these legacy systems that for many different reasons they weren't able to get rid of, the customer wasn't able to take advantage of this very rigid and strict set of integrations that exist. And that's where we really hope that NLIP can step in this context. So now let's go ahead and talk through some of those agent communication protocols, and please feel free to stop me if there are any questions that we could go ahead and go over. So as for these agent communication protocols, there are three that I'll mention today. So one that I'll mention is the Google A2A protocol. I actually didn't use this one as a part of my project. This is an open protocol for agents to discover and collaborate across systems. So you can think of it as the ability for a bunch of different agents to work together using these individual cards, like a business card, that is more like a menu of services, the things that it's able to do, et cetera. Really what this is allowing you to do is allow agents from different vendors, frameworks to delegate and coordinate work. The Linux Foundation are the people that are governing this. This includes Google, AWS, Microsoft, Cisco, Salesforce, ServiceNow, etc. Model Context Protocol is one that I worked with pretty extensively as a part of this use case. And this is an open protocol for secure two-way communication between LLMs and external tools or data. So you can think of MCP as a server that your agent can leverage in order to accomplish certain goals. So there's no Gen AI generally, and it's not like generative AI by default like an agent would be. Instead, this could be something as simple as like date and time operations, which we know LLMs are notoriously bad at, or this could be something more advanced like retrieving data. So this is to avoid building separate custom integrations for every tool and data source, and it enables models to fetch live data and tools via a single standardized interface. This is supported by Anthropic and as well as developer tools like Replit, Codeium, SourceGraph, with MCP server integrations for GitHub, Slack, AWS. It's a really cool standard, definitely one that I'd recommend taking a look at. And then, of course, we have what we're talking about today, Natural Language Interaction Protocol. So this is an open protocol standardizing how all these agents and services use natural language and multimodal messages to ensure consistent UX and interoperability. It's really an umbrella protocol. So in the example that I'll talk through today, NLIP is actually joining the system as a layer between ServiceNow's cloud and the locally deployed MCP server, so that it can actually perform different operations, enforce security, etc. This has ECMA governance, including IBM, ServiceNow, Hitachi, Microsoft, Purdue, Indiana University, University at Buffalo, Fordham, etc. So NLIP is really coming in as that overarching, very well standardized and universal or international standard for governing these types of interactions. So now let's go ahead and take a look at how we leverage MCP and NLIP in order to accomplish our use case. So I'm going to go ahead and show this solution design overview first to you. First, I'll show you right here. This is where our NLIP interaction is happening, is between our locally deployed mid server and our local NLIP server. This NLIP server is a client of the MCP server that is locally deployed. And this MCP server is where we're going to have all of our different integrations to pieces like Active Directory. And so this use case that I built was actually centered around locking and unlocking Active Directory accounts from a local Active Directory using ServiceNow. This is kind of the structure of everything. I was also using a local Olama deployment to power all of my Gen AI capabilities. And we'll talk through that in a bit more detail here coming up. But as you can see, this is where that NLIP happens, is between mid server and NLIP. And then we also have our MCP server that is running MCP. So now let's go ahead and talk through this solution in action. So let's take on the persona of an HR agent. So this HR agent is reviewing a case. They realize that a user, John Acme, needs to be let go due to a policy violation. Because of this is going to require that access be suspended across all the systems. This HR agent doesn't know what all the systems mean. They might not even know which systems they had access to originally. Just their job title and that they've made some type of policy violation, and so their access needs to be terminated. What they'll do is they'll go in, they'll update that case inside of the ServiceNow cloud instance, and this is going to trigger a ServiceNow agentic workflow. This agentic workflow prompts an AI agent to take action and read the case, leverage the NLIP client agent to contact an on-premise NLIP server and take action. Now, this contact to the on-premise NLIP server would be something like, hey, and we'll walk through this in more detail later. Hey, we need to disable the account of John Acme, all accounts of John Acme. So again, ServiceNow doesn't even have to have consciousness of what types of things are deployed on premise, et cetera. All it is letting it know is, hey, this is the user and they need to have their access disabled. So now the NLIP server receives this NLIP's request, is able to take action using MCP tools and return the NLIP response with the result. ServiceNow's AI agentic workflow is able to leverage that NLIP response to prompt other AI agents to update the case, saying that it's been the action has been taken, and then the HR agent is able to receive that notification. So as you can see, NLIP is now able to operate as that flexible layer where the HR agent is able to say, hey, I just need the accounts disabled. ServiceNow is able to repeat that out to that NLIP client agent, which is going to contact that NLIP server. That NLIP server is locally deployed, and it is what's conscious of all of the different things that this user might have access to, et cetera. And so it's able to reason through going and disabling that Active Directory account as well as any other accounts, and then coming back and letting you know that all of the access has been disabled. All right. So let's go ahead and dive into how NLIP is very effective in this specific use case. So why NLIP? The first piece is adaptability. So APIs are able to change quite frequently. It's difficult for humans to keep up with, and changes can cause issues and break APIs. Many of the APIs involve complex formatting. So for example, in this example, the Active Directory, those LDAP queries are very specific in the formatting they have, and if there's anything that's a mistake in there, then the operation simply won't be able to happen. So it's very, very specific, meaning that agent in ServiceNow would need to have an enormous amount of knowledge in order to be able to accomplish this operation effectively using just MCP. And that's where NLIP is able to bridge that gap. So on the requester side, APIs don't need to be maintained, and complex formatting doesn't need to be completed. For example, that LDAP that I just mentioned. Models can be specialized to the role instead. So on the requester side, we're really trying to have all of that reasoning and planning. We're not so much trying to make sure that we can format LDAP queries correctly. Then on the server side, APIs can be updated more frequently and maintained by those teams that are more familiar with Active Directory. The model can be chosen and tuned based on local requirements, and we can ensure that we have the proper type of performance that we're looking for at a very granular level. So we could even say for this type of query, we want to use this type of model that we've specifically fine-tuned for this purpose, but for this other one, we can use a smaller, lighter weight model. So all of those choices are now available to you, whereas previously you needed that one agent to be able to accomplish everything for MCP to work. This also offers a layer of security. So the first piece of this is the adaptive DLP that this allows you to have. So this is able to leverage semantic understanding to detect policy violations that don't match simple regex. So imagine that there is some information being passed back and forth. For example, in our example, the ServiceNow Cloud instance doesn't have consciousness of what types of services are deployed on-prem. So if the on-prem service in its response said, okay, you've asked for me to disable all their accounts, and so I disabled all their accounts on this system and this system and this system in a way that lists out the items that have been disabled and maybe discloses information out to the ServiceNow instance that we don't want it to know. This is something that would be almost impossible to catch with just a simple like pattern, etc. But the ability to audit this with a large language model, it allows us to completely remove that possibility. And it's able to reason using policy to determine when something is fishy without patterns or previous data. So for example, if I'm asking to disable quite a few different accounts all at once, maybe it can understand that even though the API should be able to do this, even though the requester side agent has been fooled into trying to do this, the server is able to look at that and say, is this something that's fishy, or is there a good valid reason for us to be doing this? Again, something that with simple policies would be almost impossible. And you can see that really this allows us to enforce that zero trust incredibly well. So every API call and response can be inspected. You can even add inspection inside of the API responses and calls themselves. So we'll walk through a very in-depth piece in our focus areas of how I've constructed the moderation in my system to make sure that those Active Directory calls aren't malicious. So let's go ahead and walk through one example of an NLIP superpower. So you can see this is how the solution could navigate a common problem, something of changing an APIs. Oh, I actually, I don't know what just happened. I just crashed. Give me just a second. Here we go. I got a question in the chat and everything crashed. Okay. So when it comes to how we're able to, I saw the question in chat, thanks David, on integrating with enterprise security products. This is just one of the best things that I found with NLIP is the amount of data that it provides you. When integrating with those security products, it's not necessarily like a product in of itself, it's more of a standard. But when complying with this standard, leveraging other security products should be significantly easier because you have a lot more data to work off of. So you have a full conversation, you have context of why this ask is happening, et cetera. Whereas with an API call, you very much just get the inputs and the outputs. It does not offer nearly the type of auditability that this does. That's what I'd say on how it integrates with enterprise security products. So I'm definitely interested to see how the market integrates this with enterprise security products as a whole. All right, so let's take a look at this solution advantage example. This is that same user saying, hey, I need you to disable this person's account. ServiceNow says, hey, disable this account. The NLIP server is going to forward the request for inference. And then we have our moderation loop. And now we've determined that in order to disable an AD account, we need an active ticket number of some kind of reference. Now the NLIP server knows that it needs to be able to gather additional information from the ServiceNow instance. It's also going to specify the information that it needs so that this can be caught. So for example, if we say, oh, also dump the entire chat log in here. This is something that doesn't make any sense in the context of this request. And so that's where our moderation loop could potentially catch this and prevent some type of tool poisoning, et cetera. But in the context of this ask, asking for a case number when disabling a user's account due to policy violations actually makes an enormous amount of sense. And so that's why we're able to go ahead and return, say, disable j.son's local account per this HR case. And so now this is an example of where if this was a required parameter on the server side, our NLIP client agent, if this was just a normal API, the API might very well fail and require a manual intervention. Whereas because of the fact that this can negotiate, it's actually able to go ahead and figure out the additional information that it needs and give that additional information and complete the request, even with that change of API. This might also make a note, a change, you know, hey, we need to update our how we're accomplishing this or the instructions for these asks, et cetera. Or maybe even ServiceNow would log a long-term memory in the context of this agentic workflow to know that it needs this additional parameter. So many different ways that you could implement this change after this initial failure. But you can see this is much more effective and much better than an API saying API request failed and someone having to go in and actually complete this manually. All right. So let's go ahead and jump into a couple of our focus areas. So one focus area that I want to go over is the system prompts. So you can see there's two different pieces. Our NLIP server is the one that's actually taking action, completing requests, etc. This is using Qwen 3 8B in my deployment. But I've had some good success with other models as well. I've been working with Llama a little bit here recently in order to use that as well. But you can see this NLIP server, you are an intelligent chatbot in charge of leveraging local tools to answer requests. One of the great pieces about how I've constructed this is that this NLIP server does not, I don't have to include any moderation text at all in here, which helps greatly with the tool calls and keeping things kind of separate. This one can focus on doing the exact job that it's supposed to be doing, which is completing the request as best as possible using the information provided. Now we have our moderation agent, and this is running in the proxy server as this is Granite 3.3, the 2 billion parameter version. So this is a content moderation agent monitoring chatbot and agent-agent messages and conversations. You can see we can include messages, legitimate tool calls, etc. One thing I noted is that because it didn't understand that there were tool calls happening before I added this bit into the prompt, it was calling a lot of legitimate tool calls as jailbreaking attempts. And so by adding this in, I was able to really reduce the number of false positives there. So your task, decide if the candidate content is non-compliant with content policies per the below steps. And you can see I define compliant, non-compliant, and then I actually got the best results even with trying to mess with it, et cetera. It was able to recognize properly when telling it to return compliant when uncertain. Oftentimes, again, tool calls that were legitimate tool calls, when I had this returning a non-compliant, which you would normally say default deny, it was really hitting a lot of those tool calls. But now it really has to be relatively certain that it is an actual nasty call before it will go ahead and say that it's a non-compliant call. I found this even across 10, 15 step interactions where I'm getting legitimate tool calls, and then I try and insert an illegitimate tool call. This structure of having one that's always trying to do the best it can to solve things and one that's always looking for the issue with it has been really, really successful. I also, of course, was able to leverage the faster inference of a 2 billion parameter version for my moderation loop, which is much better. Another thing to, of course, keep in mind here is that I could potentially use something like the 8 billion parameter version for my instrumentation and the 2 billion parameter version for my moderation of Granite 3.3. But it's best to keep your model pipelines separate when doing moderation. What one model thinks is okay, generally it will think is okay in the same if you try and bring it into moderation. So with two different sets of eyes, two different models, that's really where I was getting the strongest results out of this. Previously, I even tried using like Granite 3.1 MOE with higher parameter versions, etc. And I was still getting that same type of result where they agreed with each other. Okay. The next area I'd love to focus on are the NLIP message structure. So you can see the structure has very recently been made concrete, but when I was building this version, it was still a little bit loose. So this is the structure that I've built, but please note that some of the documentation has been released that's a little bit updated. Definitely make sure you reference that. That was, I think it was released a couple days ago. So the message type is one field. I was using request and response. I also had a system error. So just in case the moderation came back and said that it was bad. We have a format. That way we know exactly how we should be breaking this apart. Subformat of English US. We have content. And this is actually inside of the content I used an intent. This is something that I had some really great success with because it's specifying what is the intent of my ask, and then if I'm coming through and saying something different than what my stated original intent is inside the actual message itself, this is where that content moderation could potentially catch a jailbreaking attempt, etc. And so I had some really great success with putting in an intent in the content and then actually leveraging the sub messages to list out each of the messages inside of a given conversation. Obviously, each side parses its own so that you just send back and forth, or it stores its own so you just send it back and forth. But this just makes it a really clean and solid implementation, especially as you're working on that content moderation. Because it says, hey, this is what it should be, this is what the intent should be, and then we get into the actual content of the message to determine if we were actually doing what we said. To zoom in on that content moderation a little bit, you can see it's an 8-step process to be able to process a typical call. So the first thing that we go to is submitting a request for OLAMA. So this is that NLIP server, which is a client of the OLAMA server. We are then that proxy is going to extract content, submit to the moderation model, which is Granite 3.32b for evaluation. And then OLAMA will receive, process, and return. That's when the proxy evaluates that response. And this is where we get that compliant or non-compliant text. And then we'll reject the request with proper tag if non-compliant, or we'll forward the full request to the instrumentation model if it is. We then receive our forward request, process, and return. Our proxy then extracts, submits again for evaluation, and then OLAMA evaluates, and the proxy receives the evaluation and can return the response. Now, the value in catching this at every single step is that we can catch a malicious conversation or malicious action the very moment that it happens. We don't catch it at the beginning of the conversation, at the end of the conversation. We don't only catch it at tool calls. With every time that we make an inference with generative AI, we're processing that inference to determine if something malicious has happened. So this can catch things, not just malicious parts from the requester. This could catch malicious pieces inside of our server. So tool poisoning from the MCP. If we start asking for parameters that don't make a lot of sense in the context of our ask, this can be a huge gain as far as the security goes. All right. So another focus area that we can talk about are the MCP vulnerabilities that this architecture is able to account for. One of these vulnerabilities are the prompt injections. So this is where our content moderation layer catches attempts at prompt injection at any stage. This is where I'm saying, so not just inside of our request, but also inside of our tools. If a model is potentially poisoned and becomes malicious inside of our ecosystem that we're using, we have the security of having two separate models running inside, so we can even catch something like that. So that if a deployment goes wrong, etc., we can start to catch things before we do anything that's not good. And this can catch things. First, there's of course that request that's bad. It can also catch the response and tool call. It could also catch the tool response, where we're prompting the model with the tool response, and then of course the response after that tool response has been processed. And so quite a bit of capability there. I was getting some relatively quick times. It was under 30 seconds to resolve most of the requests. I'm still doing some testing. I have a home system, so it's not something that I would put as like a North Star as far as the latency, but definitely reasonable given the hardware it was running on. We also are handling command injection. So this is the content moderation layer is able to catch attempts at command injection from either side. So this can be request. This could also be from the response, and any point inside the response. So if any part of an MCP tool, if model, anything starts to do something nasty, that's where this content moderation layer can catch it. We're also able to stop remote code execution because of the distributed architecture. So generally the pattern with MCP servers is that they would be deployed onto like your local machine, whereas in this case the MCP server is remote to you, and you're actually connecting to an instance that is connecting to the server that is connecting to whatever system you're actually trying to operate on. And so a lot of the remote code execution vulnerabilities, especially those that are listed here, we'll be sharing this deck out, but under some of this research will be handled using this type of an architecture, as opposed to deploying that type of MCP server under your own on your own machine, or having a direct connection to that MCP server. And finally, we're able to stop tool poisoning. So tool poisoning, the content moderation layer can catch suspicious tool inputs, descriptions, or executions. So it can catch it before it executes using the parameters that it uses to execute. It can catch it after it executes using the response. If the response is malicious, we don't want to deliver that back, or we don't want to action on that response. It's able to catch quite a few different types of MCP tool poisoning attack. Now, one thing that I will note, this testing is incomplete on this. Test statements are undergoing verification. You can see that tag in the top right. So definitely take what I'm saying with a grain of salt, but this is what I'm seeing as I start to really play around with this, kind of hacking around with it, the types of things that it's able to stand up to. Here in a very short while, we actually plan on having one of ServiceNow's very own red teams go through and do some testing on this solution. So we should have some much more robust information as far as how it performs in these areas very quickly. All right. So now let's go ahead and discuss the challenges. So these are some of the challenges that I ran into and that you may run into as you start to work with NLIP as well. So the first one was LLM deployment. Between local or cloud, I decided on local just because we're working with on-premise Active Directory, so we want to make sure that we're very careful. And I'm trying to have a very serious focus on the security of the solution. So making sure that we're processing everything locally and not sending anything out to where someone else could be logging information is going to be really important, especially in the context of that content moderation agent. You also have the option to manage through the cloud through customer managed cloud infrastructure, or of course through a provider. One great one that I've been working with is Anthropic Cloud. Another one is Azure OpenAI, of course, but Anthropic Cloud has been working really, really well. When it comes to LLM selection, so I had a good breadth of different different options to be able to choose from when I was choosing out models from the Ollama deployment. Granite 3.1 is the one that I was really hoping to be able to work with the majority of the time, but unfortunately it gave me some pretty weak results. But Granite 3.3 was the exact opposite. It was plug and play, took my prompts immediately, no prompt engineering required, really worked really very well, even in the 2 billion parameter variant. Please note I'm only testing in English here. So it says that it's able to do multilingual. I didn't get into any testing of that. And then, of course, the instrumentation. So Granite 3.1 was giving some weak results in the beginning. I actually was getting tool calls in the messages, so it was improperly handling the formatting coming through the Olama server. Whereas Quen 3.8b immediately picked up on tool calls and was able to do it no problem. I probably even could have gone to a smaller variant, but I wanted to make sure that I retained some reasonable reasoning, just because I know there might be many different systems. And I also knew that those LDAP calls can be tough to format. We also have our connection method. So REST versus WebSockets versus AMQP. The biggest thing that made this decision for me was compatibility. And then after that is scale. So with ServiceNow, there's really not a capability to maintain a persistent connection through something like WebSockets, and they don't really have any offerings for AMQP specifically. But they do have a great offering, the mid server, which uses the ECCQ inside of ServiceNow. So it's a kind of a variant of that AMQP type, buffered messages, etc., and being able to pull from a queue and then give the response that you received. So that's really how I was able to connect out into the cloud. And then, of course, locally, when it comes to Olama, it only likes REST API locally. And then WebSockets, of course, is what I used anytime that I was able to. One thing I would say is that WebSockets is great in the very small scale that I was in, but AMQP, and this is something that's noted in some of our discussions, AMQP is definitely the way to go if you're at a larger scale, need to actually put this in a production environment. And then finally, for tool deployment and calling, FastMCP immediately worked for me. I really had no issues with FastMCP. That was possibly one of the easiest parts of this, with the easiest part actually building the NLIP messages. You just plop it right in and it goes. It really works out very, very well. I have to say, while I did have these challenges as I was working through the solution, I was really, really very impressed by how quickly and easily NLIP was able to plug into the architecture that I set up in my local network. I would say that 90 to 95% of my time was spent putting all the other pieces around it in place, with NLIP taking a very short amount of my time and really just me playing around with how best to use it in conjunction with that content moderation. So overall, I'd say as someone that is actively building AI architectures, working with customers that are deploying things regularly, and even someone who has a history of working with customers that have had legacy and hybrid systems that they've failed to be able to integrate completely because of a lack of APIs. NLIP really is an incredible tool for being able to kind of offer that flexible layer between those APIs that are local and your system and what you need to happen. I really appreciate the opportunity to speak about all this. I'm really, really excited about by each and every piece of it. Are there any questions at all? I want to go ahead and give some time. Let me see if I can't check the chat here.
You got one question here. Does NLIP leverage or work with any of the open source observability frameworks like OpenTelemetry?
I haven't seen any out of the box, like any libraries that directly integrate NLIP with it. However, I don't see any reason that it wouldn't be able to plug into that observability framework or any other. It would really just be about getting it all plugged in.
Yeah, Dave, it's as Will mentioned earlier, whatever architecture he required for his use case, NLIP provided that communication layer on top and interoperability. So you can think of any of your architectural complexity as being, it is what it is, and leveraging the different communication protocols, the bindings from NLIP, you can speak to your external tools.
Got it.
And
We
then
got another question here from Sushant. He asks, how does NLIP handle occasional hallucinations by relatively small LLMs?
That's a great question. So when it comes to the instrumentation layer, this is another reason that I went with a slightly higher parameter variant of Quen, is because the instrumentation can have some, the instrumentation can be very flexible, and it's able to talk quite a bit, and it has to do a lot. But when it comes to, so if it has a hallucination, it's not a huge issue. However, if the moderation agent has a problem, I actually went through quite a few different variants and variations before finally settling on Granite 3.3 2B. And I actually started with 8B because of how concerned I was. So it was really cool to be able to step down to 2. But that's where your hallucinations have the greatest risk of derailing things, is because if that moderation agent sees something and decides that it's fishy, even though it's not, it'll cut the interaction completely. And that's really the only time that one of these calls to NLIP would actually fail. Anything else is more of a conversation of whether it got the right parameters, et cetera, and negotiating those. But that would be where I'd really be the most concerned about hallucinations. And in my personal testing, it derailed quite a bit. For a short while, I even disabled the haunt up moderation because of how disruptive it was, having the conversation ended in the middle. So that would be where I'd really be most concerned about hallucination. That's a great thing to be thinking about as well.
Okay, we got a question from Nebula about hybrid environments. How do you expect this to work with respect to disaster recovery? So if there's a hybrid environment, like, is there any thought as to like who owns the record or the conversation?
If we're talking about disaster, like a failure inside the conversation, that would be dependent on which side the failure occurred. So I would say that on the local, the on-prem team, if it failed to an instrumentation or something like that, that would be something that would be more on their side. But if it failed more in the cloud, then of course you need to work on how your NLIP client agent is being leveraged. If you're talking more on disaster recovery, as far as like a power outage, things like that, that are more hardware focused, because NLIP is able to maintain that constant connection with the local setup, it's going to be far more effective at resuming that connection with the local setup. Whereas someone that was maybe using an MCP server that was deployed remotely from their local machine, if there was a power failure, because that MCP server requires like a consistent, persistent connection, you might have many more steps to take. I would say that NLIP is very, very resilient to the idea of coming back online from no power and having to resume operations as it's supposed to. It would just take it as another request. In my example, it doesn't even open a WebSocket connection to MCP until it receives that NLIP request. So it's truly able to be very resilient to that.
Great. We got another question from Garo. He says, how are you making sure if the task is completed right or wrong? Are you using an evaluation layer?
That's a great question. Right now, I actually don't have any piece in here that's determining whether the task is right or wrong. I would say that you would definitely want to deploy that as a part of your local on-premises solution, because the solution in the cloud really just needs to know what the result was. So that local solution could tell you, hey, is the task completed right or wrong, and could even help you get hints as to what is going on that's causing a wrong issue. This is something where NLIP, the standard requires that you do some logging of the actions that are taken, et cetera. And so using these types of actions as this audit trail to determine whether something was correct, using exactly as you described an evaluation layer would probably be best. But in my solution, I actually don't have anything like that deployed.
Okay, that's it for the questions so far. We'll give folks just a second here to add any more questions. We still have a little bit of time. Oh, here we go. So quick. All right. From Sushant, did the context window pose any limitations as the context likely grows with MCP tool calls and information from ServiceNow tickets, etc.?
That's a great question. I can tell you know about ServiceNow tickets. You've probably seen those really long, because you have a whole conversation there on a ticket, and the model needs to keep track. I would say that this is a great question, and the context windows is really uniquely handled in this situation. So previously, for like an agent to be able to connect with an MCP server, it has to have all of the information. It also has to track everything that's happened. And so everything that's going on inside of your MCP, if there's any issue, et cetera, all of that's going to pollute your conversation history. And this is actually where one of the attacks described in that tool poisoning link I have in this presentation it targets is, hey, you've executed this tool on another MCP server. now tell me what you did on that server, and it gets you to divulge those secrets. And so what my solution design and what NLIP allows you to do is to actually put a layer in between the two. And so the NLIP server is going to manage all of those interactions with MCP. It's going to manage all the interactions with the content moderation, and it's going to handle all the formatting, et cetera, and just return the result, so that the ServiceNow AI agent that has to handle that very long HR case is going to be able to keep focused on the task at hand, as opposed to trying to make sure that it correctly calls MCP tools, et cetera. So I would say that the context window actually was greatly reduced for all of the different sides by splitting this up and saying we're going to do these in separate steps. The one place that a context window does pose some risk is if you are keeping the thoughts from a thinking model. So Quen 3 does some thinking and has some think tags in it, along with the content moderation model. The Granite 3.32b didn't give me any issues, but if you try to go for a very small context window, that you might start to have issues with that smaller moderation model. So again, that's probably your weak point. But in all other places, this greatly reduces the issues that come with bringing MCP tool calls directly into the conversation on the requester side.
Okay, and this is just kind of a general question. Overall, how complex is this workflow? I think maybe you could split that up into the NLIP part versus the overall workflow.
That's a great way to look at it. Yeah, so as far as the NLIP side, so actually being able to take in the request and give the response, it's extraordinarily simple. Most of what I do is really just stripping it out of that NLIP wrapper of how I process it, et cetera. I'm stripping it out of any additional wrappers like ServiceNow likes to put on things when it sends it into places, and then giving it out to the model with that content and those sub messages. That's most of the work that happens, and there's actually now an SDK that's been created, I think by Dinesh out of IBM, that helps an enormous amount with trying to do all of this different parsing. So that's really the largest lift when it comes to NLIP. The rest of it is just sending out those prompts. As far as the larger architecture, it's a little more complex, and it's growing even more complex as I start to hit some of the higher levels, those phase 2 and phase 3. Or level 2, level 3 of the NLIP standards. But NLIP itself is extremely easy to use as a layer on top.
Okay, and that is it. We're starting to run out of time, but we do have enough time if there are one or two more questions. We can take one or two more. But it looks like we're good for now. All right, while we wait in case there's one more question, I do want to remind folks that next week we have, on October 30th, we have Build AI Apps Fast with Langflow from David Jones-Gilardi. He's from DataStax. So be sure to check in with that. That's a growing open source agent framework. Okay, we've got some quick questions here around just working to get the slides. Paige asks. Yeah, do you want to share those slides as a PDF file or something, and we can just let people share it with me, and I can let people download it?
Absolutely, I'd be happy to do that.
Why don't you just zip that over to me now, an email, and I'll put it in a folder where everyone can access it, if you have time.
Yeah.
All right. We got some positive comments. Great questions. Thanks for the walkthrough. Amazing questions. Great. Appreciate the opportunity and participation. Yeah. Oh, that's from you. All right. Great. All right. Well, hey, folks, if you want the slides, just stick around for a second. And as soon as Will, by the way, I've been assuming your name is Will, but are you go by William or Will?
I actually do go by Will. That's a good assumption.
Okay. All right. Cool. Yeah. It's a family name in our family, so we have goes by Will. So I just kind of naturally went for that. All right. So that's it, I think. Yep. Okay. Got another thanks. All right. All right, folks. So stick around for a few minutes, and I'll upload this file to a Google Drive where I'll make sure everyone has access to download it, and it'll be a PDF file. And until then, let's see what else do we have going on. Let's see. I am curious. While we're waiting here, Will, I've got one other question or comment. We heard from a project called Context Forge, which is an MCP. I don't know. It's like a gateway does some other things. And it seems like there could be a little bit of overlap with this, but maybe not, because this is more focused on like maybe the protocol versus like the server. Or do I have that wrong? Is this really like becoming more of a server that manages everything in between? Or is it going to stay like more of like the protocol layer, like, you know, connecting things?
Yes, this really is at the protocol layer. I might invite Sean to speak a little bit more on this one, but really NLIP is going to take that protocol side. While NLIP does offer, you know, server offerings, etc., it's a very simple and lightweight piece, really designed to just connect two pieces. So I would say definitely think of it more as a standard and protocol than as a standalone server itself.
Got it. Thanks.
Yeah, just, I mean, bear in mind what Will shared right up near the front of the presentation about, you know, what is NLIP and where does it fit into everything. You could imagine your multi-agent system supporting, you know, all different tasks and workflows across the business. And each agentic system could be built off, you know, different protocols like ATA, MCP, agency, ACP, Nando, whatever it is, whatever proprietary thing you're doing. And they really struggle to work together. And that's where NLIP provides the magic of being that communication layer, enabling, you know, both multimodal communications as well as natural language communications. And obviously we're highlighting through the natural language interaction protocol the hero in the story being the ability of humans to speak to AI agents being able to speak to other AI agents, and NLIP being the umbrella across that whole system. So you know, I wouldn't see it as competing or overlapping with, unless somehow that other system is truly an umbrella protocol like NLIP. But I would see NLIP as being the umbrella even over that other protocol that you mentioned, Dave.
Got it. All right, thanks. Let's see here. I'm going to change my settings here. And Will, do you want to email that to me? How do you want to get that file to me?
Oh, I think I already sent it over. Do you have it?
Oh, I think it's taking a while to download. Let's see. I don't know, for some reason I don't have it yet. I don't know why.
Let me make sure it's this email, correct?
Let's see here. Hold on. Yep, that's it. Emails. Yep. Okay, it's just taking a little bit, I guess.
Yep.
Huh. Okay. I'll tell you what. Here's what I'm going to do. I am going to. Let's see here. Okay, for now, what I'm going to do is let me just put this, I should have thought of this earlier. I just put this link in the chat, and I'm going to open it up for anybody to upload anything to it for right now. And then as soon as you upload the file,
Oh, perfect.
I don't know if you can see that chat, because it's not coming through for some reason. I don't know. I'm inside of maybe I'm in a firewall. I'm not sure what's happening.
No computer devices. Yeah. Oh, yeah. Yeah. So chops them out. That's bad. Seven. Yeah, I don't know.
I've got some background noise there.
Okay, it is uploaded now.
Okay, let me just double check. All right, there it is. Great. Okay, folks, so you should be able to download from there. I'm just going to go change the settings so it's not open to the world to upload anything. But yeah, so let's see. Okay, all right, folks. So if you want, you can download the file from there now. you should be available to anybody. I don't know if Tim or somebody else want to try that. Here, let me try it from a different browser I'm not logged into. So I want to make sure that that is indeed open to everyone. Yeah, it looks like it is. Okay. All right, folks. So that's it. You got the slides if you want. And appreciate you joining us and asking those good questions. And we look forward to seeing you next week. Until then, have a wonderful week. And thanks again, Will. All right.
See ya.
Take care, everyone. Bye-bye.